you're not sure what page it is, it's page 21. The pages after that are just summary reflections if you wanted to do anything. Find A if the coefficient of x to the 11 in the expansion of this thingy is 15. So first of all, the exponent's 10. How many terms will there be in the expansion out of interest?
11.
Good, 11, yeah. Because have you noticed on the topic assignment, sometimes you're asked that in past exams. They'll ask you how many terms are in the expansion. Find the coefficient. They've told you that the coefficient of x to the 11 is 15. So we know that it's going to be like 15 something x to the 11. And now we need to work backwards and find out what this mysterious thing here, A, is. So I actually tried this one non-calc just because there was a lot of space. So I thought, okay, I'm going to try this one non-calc in terms of finding the NCR. But it's okay if you don't want to do that. Oh, I wrote the top. I'm just thinking, why is my answer written at the top? But it's just because I wanted to check if I had the right answer. So I looked up the answer. So we can try this one non-calc if you want. Okay, so x to the 11 is what we need. So we need x to the 11. We don't know what the r is, and if it was just x, if it was just an x here and just a number here, it would be fine. We can go x to the 10, x to the so on, but there's an x squared and an a to the x. So it's an example of when we've got an unknown r. What is our, yes, we need to do that stupid thing. So what is our value of n? We know what n is because they told us that in the question. 10. Good, 10. Yeah. N is just the exponent here. So that can be what kind of writing down. N equals 10. That comes from there. We don't know what r is. We're going to have to work out what r is. So we can set up the NCR as 10r because we know that n is 10. We don't know what the r is. And remember the first term is x squared. And can you remember what was the formula? Is this one
10
r?
subtract r.
Good, 10 subtract r is always, it's n minus r is always going to be the coefficient on the first term. So n minus r, we already know it's 10 minus r. So we can put 10 minus r. Can you see it's one of the ones where we're going to use the exponent laws again to solve for r. And the next term is 1 over a to the x. I'm going to write it down correctly. So let's write out something different. What is the exponent on the second term always? R. Good. Nice. And we happen to know that that equals, what do we know that it equals?
15x to the 11.
Good, yeah, 15x to the 11. Correct. So if you want, you can start to write that in if you like. Sometimes I don't start to put that in until the end, but if it helps just for you to see the big picture. We're going to use all of this, and we know what it's going to be set equal to, and that's going to enable us to kind of like solve for a eventually. So we can use a little bit of exponent laws. Let's start to use our exponent laws here. Again, we don't know what r is, so you can just bring this down, 10r. What does this red bit become when you use your exponent laws?
20 subtract 2r.
Yeah, that's good. Multiply the exponents. It's an exponent of an exponent. X to the power of 20 minus 2r. Not put it in brackets. What does this green bit become when you start to use your exponent laws?
1 to the r over ax to the r.
Yep. And what would be wrong if I did that?
Put it in brackets.
Yeah, leave it in brackets. Yeah, good. Or you could write AR, XR, same thing. That would also work. So I might do that actually on the next line. I might rewrite that as AR, XR. Because we're going to kind of separate out the x's. So let's bring down our 10r again. Kind of doing this a bit more painfully than we normally would. So if you want, like, remember Grace, you like to write this as a fraction, so you're unable to see that there's a fraction going on, so that's a good idea. Let's do that. X to the 20 minus 2r over 1. It's a good idea because it helps you sort of to see how they can merge together. And because we're kind of going to combine our x's, that's why I'm going to rewrite this as a to the r, x to the r. If it helps, like 1 to the r, would you agree that it's just going to be 1 no matter what? So if you don't want to write 1 to the r anymore, you can just write 1r, ar, xr. And doing that kind of is going to help us to see how the x's are going to cancel down. If you want to keep all this kind of neat, nice and neat, we can do the x cancelling down step on the side. This is a little proof of why x cancels down. So we're kind of doing x to the 20 minus 2r over x to the r. So you'll start to see automatically what these become. You'll just realise that you're subtracting an r all the time. Over x to the r. What's that going to cancel down to?
X turning negative 3r.
Yeah, how come it's minus 3r now?
Because negative 2 subtract 1 is negative.
Yeah. So remember, when you divide and you've got the same base, you subtract the exponents and keep the same base. So if it helps you, write 20 minus 2r minus r, if you put the space, if I don't have the space there, which will give you 20 minus 3r. Because 20 minus 2r minus r will give you 20 minus 3r. Yes, Owen?
So why is it XR not 1?
This bit?
No, the other part.
In that part?
Yeah.
Oh, because when you're dealing with exponent laws, you can only deal with terms that have the same base.
So,
Yeah, so this other stuff, like 1 over a to the r and the 1, it's still there. But in a way, like we're just kind of focusing on how does that cancel down. And to kind of, you could neaten it up, you could if you wanted to move the 1 AR over here and put the XR over here. But I'm kind of a fan of doing it on the side a little bit. Sometimes it's just my preferred way of seeing things out. So that means that these two things are going to cancel down. You've still got all your other stuff going on though, so let's start to write that out. 10 to the r, and then that bizzo, we'll just put it in purple. You can. Some people like to put the coefficient at the beginning, so if you can put the purple bit next and then this number. You might want to put 1 over a to the r first. So notice that what's left behind after you've cancelled this, you've still got 1 over a to the r. I want that in green down. 1 over a to the r, and then we've still got this purple bizzo. X to the 20 minus 3r. If it helps, write it over 1. X to the 20. If it helps, write it over 1, just so that you see that it's that times that times that. If that helps. Good idea. Oh. And now what are we doing? Oh, yeah. What was the exponent on the x meant to be in the end?
11.
11, yeah.
I was going to get that step too.
Yeah, this bit here. So then the exponent must be 11. Must equal 11. So our little expression that we've come up with for the exponent, we're going to, on the side, set that equal to 11 and solve for r. 20 minus 3r equals 11. So that bit on the side. So that bit on the side went to there. So now 20 minus 3r, we're kind of doing that here. So different ways you might want to solve for it.
Oh, 20 is more.
So what does 3r equal? Oh, okay. That's upsetting. I thought I'd close it for a second. Okay, good. No, that's really worried.
It becomes 3.
Yep, you could do, I kind of do it like this. Yeah, 20, it does become 3 in the end. 20 minus 11 equals 3r. Solve it any way you like. You might want to do 11 minus 20 is negative 9. Negative 3r equals negative 9. I just do 20 minus 11 equals 3r. Swap them over. So 9 equals 3r. So r equals, as you said, 3. That's another little thing I just happen to be a fan of working out on the side. But you set it out any way you like. You're comfortable with doing. And then I just like to leave all this lined up. So we know r is 3. And don't forget all of this, remember, is also equal to, as we said at the top, I sort of stopped bringing it down a bit, is all equal to 15x11. So it's good maybe to have that at the beginning, just so you don't forget, oh, there's something we've got it set equal to. So maybe, okay, we can sub in. We know r is 3, so we can now start to set this up. 10, 3. 1 over a to the cubed, because it's r is 3. And then we know that's going to equal 11, but you might want to double check. 20 minus 3 times 3 is 11. So x to the 11. And now at this point we might want to bring down what it's equal to again. Equals 15x to the 11. I sort of stopped doing that a bit because I've got all this bizzo going on the side. But you can bring it down the whole way if you want. 15x to the 11. Does anything cancel out immediately? Yeah. So if you want to, you can cancel it out later if you prefer. It's up to you. I'm sort of like running out of space, so I might start to do it on that step. And I said let's just try this one non-calc, just to practice doing non-calc. It might help for your mini test. Practice working out this using the gorgeous formula. So it's going to take a bit of space going across. 10 times 9, 8 times 7. Now what do I start to work out on the bottom? Yeah, this one, yeah, it's like 3 factorial. Did 3 times 2 times 1 times n minus r factorial will be 7 factorial. 6, yep, good. So 7 times 6 times 5 times 4 times 3 times 2 times 1. We are going to cancel down, but I'm just also on top of that going to write the other stuff next to it. This stuff here, so I don't forget what's going on. Equals 15 because we've already cancelled out the x to 11s. And do it whatever cancelling going you can. Just practicing doing this because, as I said, there'll be a question on the mini test about the gorgeous formula, so just want to be aware that you can cancel all this stuff down. Yeah. We can cancel down further if you want. You could work out 10 times 9 times 8 over 3 times 2 times 1, no problem with that. I'm a bit lazy, so I'm going to cancel down 10 and 2 to give me 5, and I'm going to cancel down 9 and 3 to give me 3. You could have cancelled down 8 and 2 instead. So then 5 times 3 times 8, ugh, I should have done it the other way, shouldn't I? Because timesing by 10 is easy. So just that's fine what we just did then. So keep doing it that way, no problem. Where you could cancel down that is 4, cancel down that is 3, because 3 times 4 times 10 is easy. I'm just being lazy by doing that. So what's our NCR? What does 10C3 end up equaling? Yeah, 120. Should check my answers, shouldn't I? Yep, you're right, 120. What were you saying, Krista? Times 1 over a cubed equals 15. And see, we're getting towards being able to times by solve for a cubed. So if you combine all this bizzo, would you agree that it becomes 120 over a cubed, yep, equals 15. And then however you choose to solve it is up to you. Like you might times by a cubed first and then divide off 120. Or you could go straight to 120, divide by 15 equals a cubed.
Wait, what did you just say?
So, in a way, like you could have just times over the a cubed and then divided it off. Yeah, I was just getting a bit lazy again, just deciding I wanted to do it both in one step. Some of you might be used to the triangle of death as well, like with speed, distance, time. That equals that divided by that. No, that equals that divided by that. And 120 divided by 15. What's 120 divided by 30?
40.
4, close, yep. So 120 divided, yeah, I would have thought the same thing. 120 divided by 15 therefore is? That is a nice cube number. 8, yeah. If you were to do it non-calc. So maybe just show that. So what's our A got to equal? 2. Woohoo. And if you had time, that's all done. All they wanted us to do was find A.
What is it? 8?
2. Yeah, a cubed equals 8, so a equals 2. Yay! So it was a good one because it had a bit of, it was an extra challenge just because it had a lot to it. Like you had to find R, I'll move down. You had to find R, you had to, R3.
N is the row and R is the number within the row, which is confusing because you think it should be
Oh, so R is your alpha.
Yeah, like the first, like the position of the in the binomial expansion. Like if R is 0, it means it's the first position. It's the first term. If R is 1, it's the second term. If R is 2, it's the third term. Like N1, like 12, 0, 12, 1, 12, 2, 12, 3. So it's an indication of where in the binomial expansion it is. The position starts with 0. Okay, so some of you might have been writing that down, so I'll leave that back there. And I'll just... Do you have any questions about any of that while we're here too? Like, there's heaps of using this procedure at the top. In the topic assignment, you might have noticed there's heaps of finding R. There's heaps of finding R ones. You've probably picked up on that. Yeah, almost to the point you're like, oh. So,
Tomorrow, right?
yeah, but you can work on it today. Well, we've got mini test 1, but you'll have time to work on it still. And if you've got more questions tomorrow, that's okay. You can ask in tomorrow's lesson too, or finish some things off. Yeah, so that's due tomorrow. It's very repetitive. Pretty straight up. Do you want to... I would say you wouldn't need more than 30 minutes. Do you want to start at like 9:15? Sure. Yeah, that gives you wouldn't need more than 30 for this. Like 20 you'll probably even be heaps. What? Yeah? Oh, I should stop this. Goodness.